Welcome to this demonstration entitled An Extensible and Reusable Pipeline for Automated Utterance Paraphrases. As we know, conversational AI is shifting the way we interact with digital information and services. We can now interact with these by simply uttering a request and getting the desired response through a natural language conversation. However, allowing user to converse naturally with services and perform their task is challenging. For example, user can express the same request in many different ways. So, conversational AI systems need to be trained to deal with this richness of human language. This requires collecting large and linguistically diverse datasets. In this context, paraphrasing is very appealing. Paraphrasing is a natural language task that aims at reducing lexical and syntactical variation of a reference utterance to generate new but semantically equivalent sentences. Traditional approach to paraphrase acquisition, such as hiring expert or crowdsourcing, involve processes that are often costly or time-consuming, and with their own trade-off in terms of quality. Automating paraphrasing is emerging as an attractive alternative that provides a fast, scalable, and cost-effective process. In this demo, we introduce an extensible, reusable, and configurable pipeline that unify, integrate, and extend automatic paraphrasing technique. The pipeline organizes the generation in two steps, namely 1. Paraphrase candidate over generation, supporting techniques such as pivot translation, weak supervision, and transformer model that can be combined to generate candidate paraphrases. And 2. Candidate selection, with pre-trained language model and techniques to discard semantically irrelevant and duplicate paraphrases. Let us show you how this pipeline can support two main use cases, the generation and evaluation of paraphrases. For this demo, we developed a simple web interface that interacts with our proposed framework. So in this interface we can plus the input sentence that we want to paraphrase, we can select and tune one of the pipeline currently available in the system, and then get the result, which is a set of paraphrases for the input sentence. Alright, now let's say we want to generate paraphrases for the sentence which company make the iPod. As we mentioned, we can select configuration that include individual technique or combination of techniques. Let's start by trying out a configuration with an individual technique, weak supervision. This is a technique that focuses on introducing lexical variation by replacing individual words in the input sentence with synonyms. Now the two-step process we implement also include candidate selection. To show you the benefit of the candidate selection step, we will first run the pipeline without this step. Let's have a look at the results. We can see that weak supervision indeed introduces lexical variation, but also that the results are a bit noisy. However, running the same configuration with the candidate selection on, we are able to reduce the number of duplicate and semantically irrelevant paraphrases. We include a paraphrasing service based on T5, a transformer implemented by Google, a type of neural network architecture. By default, T5 does not perform paraphrasing, so we train it on the Cora question pair dataset for paraphrase generation. Applying this technique, we can see that the result, as opposed to weak supervision, provide good syntactic diversity, change not only individual word but sentence structure. The pipeline then allows users to combine techniques. For example, knowing the characteristic of the previous technique, we can run them in tandem, applying first T5 to achieve syntactic diversity, and then weak supervision for lexical diversity, or in an ensemble. Some combination are already built in, but the user can also implement more complex pipeline by leveraging the Python APIs we provide. The framework can be used to evaluate existing and novel pipeline. We can use the command line tools to run the desired pipeline and set the evaluation parameters. Then, when evaluating the pipeline, a reference benchmark dataset is loaded by default, and the framework generates the utterance paraphrase along with the evaluation according to relevance and diversity metrics. These are also generated after executing each component so as to support ablation studies. The output can then be used by a researcher to draw comparison and perform analysis. Thank you for listening. Please check out our paper for details and the GitHub repository to play or contribute to the framework.